Welcome back, Algebros. We are going to be taking a look at functions and determining if they are even or odd algebraically. So, even functions, all of the exponents are going to be even, and a constant has an exponent of 0, so therefore it is even also. If you replace an x with a negative x and you end up with the same function, then it is an even function. So if we take a look at their example there, on all of their x values they add a negative, and when you simplify it out, you end up with the exact same equation that you started with. For odd functions, all the exponents need to be odd. If there is no exponent present, then it is understood as 1. If you replace x with negative x, you end up with the opposite function. So if we take a look at this example here, they add a negative to all of the x values or x variables. And as you can see, we have the opposite sign on all of the terms that we started with. That would be an odd function. All right, so let's try it out. We have f of x equals negative x cubed minus 2 times negative x. So when we simplify this, if we have an odd number of negative signs, as we do here, we have negative x times negative x times negative x, the answer is going to result in a negative value. So we would still have negative x cubed, and negative 2 times negative x would result with a positive 2x. And if we look at our starting point, we have a positive x cubed minus 2x. And here we ended up with a negative 3x plus 2x being the opposite. This would be an odd function. Number 2. So looking at it, this has the potential of being an even function because we have an exponent of 6 and 4. So those are even exponents. So if we substitute a negative in for all of the x values, when a negative is raised to an even power, there's an even amount of negative signs, so they cancel each other out, resulting in a positive value. So negative x to the power of 6 would result with a positive x to the power of 6. Negative x to the power of 4 would result in a positive x to the power of 4, and times negative 3 would leave us with negative 3x to the 4th, and there's nothing being multiplied to 2, so it stays as 2. So if we take a look at our original function, which was f of x equals x to the power of 6 minus 3x to the power of 4 plus 2, and our resulting equation is exactly the same, therefore it is an even function. Number 3, right away we see we have an odd exponent and an even exponent. But let's see what happens algebraically when we substitute that negative in. All right, so now when we go to simplify, negative x to the power of 3 will stay negative x cubed. Negative x to the power of 2 will result in a positive value because there's an even number of negative signs, so plus x squared. And negative times negative x would result in a positive x. So as we can see, our first term from the original equation and the first term from our new equation are opposites. We have positive x cubed and a negative x cubed. Our middle term is a positive x squared and a positive x squared in our new equation, which is the same. So right away you can see we have one value that changed and one value that stayed the same, therefore breaking both rules. So this would be neither even or odd. Got 3 more examples. So number 4. All right, when we substitute a negative on the x variable and we go to simplify, we still have that negative 3 outside. Negative x to the power of 4 would result in a positive x to the power of 4 plus 7, and we can see that our equation is exactly the same as we started with, meaning it is an even function. Number 5, right away I see an even power and an odd power. So pretty sure that it's going to be neither, but let's just see what happens when we substitute that negative in. Let's keep our work consistent. All right, now that we have that negative in there, if we simplify, a negative to an even power will result in a positive solution. So we have x to the power of 4, and 2 times negative x would be a negative 2x. So we see our first term stayed the same, but our second term became the opposite. We went from positive 2x to negative 2x. So since one changed and one stayed the same, it broke the rule of both, so it is neither. And let's take a look at number 6. When we substitute a negative onto all of our x's, and we simplify, a negative to an even power, so the power of 2 would be even, is going to result in a positive value. So we still have positive x squared minus 5, and we can see that our new equation is exactly the same as our original equation, meaning this is an even function. All right, go ahead and drop a thumbs up in the chat so I know that you watched this second video. And now, after watching the first 2 videos, you should be ready for your assignment, and you have to do all the problems on the assignment today. So for the algebraic ones, please upload a photo of your work along with your answers. And as always, happy mathing.